Hello, I am Josh Waters, Product Manager for Dwyer Instruments, and I will be reviewing pressure sensor accuracy. The purpose of this video is to give you a better understanding of the factors that go into accuracy and how manufacturers combine these factors into an overall accuracy. So why is pressure sensor accuracy important? From a manufacturer's point of view, the wrong sensor can cause expensive quality or efficiency problems. This is why it's important to understand how manufacturers calculate accuracy and recognize what parameters to look at when comparing pressure sensors. By understanding how manufacturers calculate accuracy, you will be able to make a more informed decision when evaluating pressure sensors, ensuring that the next sensor you select will have the required accuracy at the right price for the application. So what is accuracy? The International Electrotechnical Commission, or IEC, defines accuracy as the positive and negative deviation from a curve observed in a testing device under specified conditions and procedures. Unfortunately, when it comes to defining accuracy for a pressure sensor, it's a bit more complicated. Accuracy has a large effect on the cost of the pressure sensor, or even more important, on the quality and efficiency of the process it measures. It's important to understand the factors determining accuracy and what questions to ask when selecting a sensor so that you can make a more informed decision when comparing pressure sensors. Even though there isn't a defined standard for pressure sensor accuracy, there is an IEC standard that defines the factors that make up accuracy. IEC 61298-2 states that accuracy must include hysteresis, non-repeatability, and nonlinearity. Hysteresis is the difference between the maximum deviation in the output between consecutive increasing and decreasing cycles. Non-repeatability is the maximum difference in the output when the same pressure is applied consecutively under the same conditions approaching from the same direction. Where manufacturers start to differentiate is with nonlinearity. IEC 61298-2 lists three methods of nonlinearity. The two most popular methods used by sensor manufacturers are the best fit straight line nonlinearity method and the terminal point nonlinearity method. Usually the nonlinearity method used for the sensor will be specified under the sensor accuracy as best fit straight line or terminal point method. This is why it's important to understand the difference between these two methods. Based on the characteristics of the sensor, it could have two vastly different nonlinearity percentages. Based on the following diagram shown here, you can see that the same sensor has two different nonlinearity percentages based on which method is used. IEC 61298-2 identifies the factors that make up accuracy, nonlinearity, non-repeatability, and hysteresis. But the IEC standard does not define how these factors are combined into a single accuracy. The method in which these values are combined can have a substantial impact on the total accuracy. Some manufacturers simply sum the factors, while other manufacturers use mathematical equations such as root of the sum squared or root of the mean squared to combine these factors into an overall accuracy. As seen in our example, by using the same nonlinearity, non-repeatability, and hysteresis values, the accuracy of the same pressure sensor can vary over 0.3% based on which equation is used. Dwyer Instruments specifies an absolute accuracy for its manufactured pressure sensors. What this means is that the output or reading of our gauges and transmitters will fall within a plus or minus specified accuracy from absolute. For example, if you have a Dwyer 628, which has a specified accuracy of 1% full scale, with a range from 0 to 100 psi, any reading you take from that 628 will be within plus or minus 1 psi from absolute. By specifying our accuracy this way, it makes it very easy for you to check and validate our pressure sensor accuracy. All you need is a reference device to compare our sensor to validate the accuracy. For those sensors that use equations to formulate the accuracy, it's much more difficult to validate if the pressure sensor accuracy is correct because it can vary widely based on which equation was used to calculate its accuracy. I hope this video has given you a better understanding of pressure sensor accuracy and will help you make a more informed decision when selecting pressure sensors in the future. And as always, I'd like to thank you for selecting Dwyer Instruments for your instrumentation needs.